Hey everybody. Today we're talking about mean, median, and mode from the perspective of understanding. These are all ways of measuring the center of a data set, and they're all useful in their own right. To start is the mean, and that's the sum of the values in a set divided by the number of values. It's just the numerical average. So for instance, here we have 16 values. We add them all up, we divide by 16, and we get 67.9375. And if you look at the numbers in that set, you can see that 67.9 is right about in the center, although not exactly. If you notice, it's in the sort of half of the data that has the higher numbers. Secondly, the median is the value that splits the data set exactly in half when the set has been ordered. If n is odd, there's exactly one data point in the middle, so that's the median. And if n is even, you have 2 points in the middle, so you got to take the average of those two. That is, you go halfway between the 2 points in the middle. Looking at that same data that we looked at a moment ago for the mean, we have them ordered here. We have an even number of values. The median is going to be halfway between the two values in the middle, 65 and 66. So the median is 65.5. Finally, the mode is the most common value. A set can have more than one mode if you have two values that have the same frequency, the same sort of maximal frequency, or a set can have no mode at all if all the frequencies of every observation in the set is the same. Using that same data, here the mode is 65, it's the most common value. Now, in this case, that happens to be kind of near the middle of the data set. That's often the case, but it doesn't have to be. You could easily imagine a situation where instead of having 4 65s, we have 4 58s. Each of these measures of center has an interpretation when we're looking at visualizations of the data. The mean corresponds to the balance point of a histogram. So for the data that I'm showing here, if I sort of hold my finger underneath this histogram and try and find the place where the histogram balances on my finger, that'll happen at around 3.7. The median corresponds to the value that splits the histogram's area in half, and in this case that's at around 3.1. Remember that in a frequency histogram, counts are represented with area. So if we're splitting the area in half, we're splitting the counts in half. There should be half of the values in the data set to the left of that vertical line, and half of the values in the data set should be to the right. Finally, the mode corresponds roughly to the tallest bar of the histogram, and in this case, that's near 3. Now, if you're dealing with continuous data that can take on an entire range of values, this won't be exactly right because you're unlikely to have multiple values with exactly the same value. Here, when I say the mean corresponds roughly to the tallest bar on the histogram, you have to take into account the binning that occurs when we make a histogram. Now, each of the three measures of center has advantages and disadvantages. The mean is the most common one when we're doing statistical inference, and so it's important to be able to compute, use, and understand. It's one that is a little bit more intuitive for a lot of people because we tend to learn it at a fairly early age in school. Unfortunately, the mean is highly sensitive to outliers because extreme values have a large effect on it. That's just sort of how the mean process works. We add up all the numbers, so hugely big numbers have a big effect. The median is simple to compute, and it's very easy to understand, and it's not sensitive to outliers, so those are some really big advantages. Unfortunately, statistical inference, which we're ultimately wanting to do when we study statistics, is more difficult with the median. It's harder to reason from a sample to a population when you're talking about median rather than mean. Additionally, the median only considers the order of the values in the set, not their relative position. So it does not take into account that a certain value might be much larger than the median, or much smaller. It only takes into account that values are larger or are smaller. Finally, the mode is the most universal, and it's meaningful for any distribution, even one where we're talking about categorical variables. However, the most common value in a data set often doesn't lie near the middle of the distribution, so the mode is unreliable as a measure of center. It's also something that we don't typically use for statistical inference. One final example to wrap up this video. We have a small group of students and we have their scores on a math exam, 95, 94, 94, 93, and 19. So the mean on this exam is 79. You just add them all up, divide by 5. But this is not a good description of a typical student. It's not really in the middle here in the sense that we want to use the word middle. The median, 94, is more descriptive of how kind of the class is doing on this test. One indication of all this is that if we remove that outlier, if we take 19 out of the set and recompute the mean with just the 4 remaining values, we get 94, which is radically different than the 79 we had before we took 19 out. On the other hand, the median, 94, doesn't change at all when we take out that one value. And this is typical. If you take an outlier out of a set, it tends to affect the mean much more than the median.